Hiya guys, and welcome back to Wade's Workshop. So today we're doing a little job for a subscriber, not something I do all the time, but we are in this case. And what we're going to be doing is modifying a quick change tool post, an eBay quick change tool post. It's actually very good quality, but we're going to modify it to fit the Warco WM180 lathe. So let's get to the table on the milling machine and I'll show you what we're going to do and we'll formulate a plan. Cheers now. So I got this little tool post. A subscriber has reached out to me and asked me to modify it for him so it'll fit his 180 Warco. It's shown as a treble zero, 250 treble zero. I think it's a little bit small for the Warco, but we can certainly make it fit. I probably would have gone for the next size up. Now, two options. It's got the right size thread and it's got a nut on the top. And it comes with this little subplate which is probably designed to go into a T-slot or something like that. So the stud is correct, and obviously it won't fit onto his machine because this plate is tapped and there's no rebate for the, I think it's 18mm boss on the top of the compound. Let me get the compound out and I'll show you the issue. I've just dragged my compound out of hibernation, and as you can see, I mean, obviously as it comes with a stud. We need to put it on there. Now, the Warco has this boss in the top of the compound. So obviously that could go directly onto there, but then we get that problem. Now, the issue I can see here is that if I was to bore out the bottom of this, which I'm sure one way or another I probably could do, we're going to be even lower with a tool post. So I'm thinking that this tool post actually needs to go a bit higher, so I want to use this plate. Now the problem with using this plate is that if we just put that on there with the right size hole in, obviously we're going to lose the register, the boss on the bottom. So I think what we're going to need is a new plate. Yeah. Don't know. I was thinking of making a new plate with a register on it, but then I'd have to cut the register on the underside of there. I think, especially the way this tool post is designed where it's just a plain hole, I think what we'll probably get away with is boring a hole in this plate to fit over this register, which I think would be step one. So I'll just pull out the standard Warco stud. Okay, the threads are a little bit shorter on the new one, but there's more than enough there. Could do with a couple of flats on there to be able to do it up. I may machine a couple of flats on there to allow that to be done up. So we'd need a hole in that plate so that that fits on. Then that would go on there, on top. And then nut-wise, that would fit about correctly. So yeah, we have a cunning plan. Let's see how hard this plate is first, whether it's hardened or not. So, quick, simple way to do that. File, any file. So let's just do a scratch test. Soft. Okay, that's good news. Okay. Need to put this plate up, I suppose. Should we do it in the lathe with a 4-jaw? Perhaps so. And bore the plate out to take that register first of all. So that's going to be step one. I was just about to set this up on the mill with a view to boring it out on the mill, but then I was thinking, if you've got people that haven't got a milling machine but they have got a lathe because they bought a quick change tool post, perhaps I'm better off doing it on the lathe. So I think that's what I'm going to do. So 4-jaw chuck for a square plate. As you can see, it's all shapes at the moment. So I put the 10mm stud in the 10mm hole, or M10 hole. Alright, let's just do a couple of cheats. So I'll put my chuck in. Hang on, let's just wind the quill out. So chuck, I tell you what, let's just loosen off the chuck. I haven't set it at all, so that's all wobbly in there now. Open up the chuck, stick it in there. Okay, so as you can see, I've got the rod inside the drill chuck, which is keeping that rod in axis this way. So I've got a rough flatness of this plate. True. Now, as you can see, I'll just bring all the jaws off, shall we? Okay, so I'll just tighten the chuck, and that's free to move. Oh, tighten up the drill chuck, that's free to move in there. So it's in a bit far. Let me just bring the front face out a couple of mil. Okay, get somewhere near, and I'm just going to wind down to a touch. That's touching. Yeah, it would have been. Okay, just a touch without turning the chuck. Just a touch. One on the back face. Just a touch. Let me just loosen the chuck off now and bring that out of the way. Okay, that fell out. My touch was not hard enough. Bring that one somewhere near. So as you can see, it still moves around in there. Let's just come back in. Line that up again. Didn't quite work to plan. That was supposed to stay still. Okay. So we got them all. Right. Rather than just a touch, let's just nip those two, then come out. Okay, so I'll just nip these two now. Only nipped. Right, so we got ballpark, and that rod looks pretty straight. You know, it's not waving about in 3 dimensions, as it were. So I think the first thing I'll do is clock up the rod at this point here. A little less. That's getting very close on that axis. This one's high. High point somewhere between these two. Okay, I'm within a thou there on the shaft. You've seen me clock stuff up before. And that's now running quite nicely. Let me just, I'll tell you what I'll do. I haven't used it in a while. Get my little pusher on here. And pull that stud back out. Oh, attempt to. God, that's gone tight. That's probably where I've squeezed the plate. Hang on, I gotta. That's where I could do with 2 flats on here. I will machine some flats on. That'll be a handy little. Okay. Handy little thing to have for the gentleman who's going to be fitting this and using it in the future. You'll have to come in. Okay. So a little pusher tool. Right, let's just turn the lathe on. Make sure nothing's fouling. And we want to give that a little bump. Get it straight. I'm going to have to give it a bit more of a bump. Where's my little tapper? I'm doing a useless job on this today. Let's have a look at this now. It's pretty good now. Let me just double check these jaws now. Make sure we got all four tight. There's still more to go on these. But as I'm doing the bore in this plate and the outside of it doesn't do anything, it's not got to be clocked up super accurate. As long as my bore is square to this face, which it will be now. Okay, so yeah, I made a bit of a botch of that, guys. Not a very good demonstration, but pretty much the tapped hole that's in it at the moment is central about, and the front face is flat in the forejaw. So let me just double check. I think 18mm is what we're looking for. Yeah, the boss that's showing on my compound is 17.9. I'm going to put an 18mm hole in. That seems to be what I've done on all of the ones that I've done so far. So I think the first thing I'm going to do, or attempt to do, is drill a 16mm hole through here. Yeah, 16. We'll try it. Let's just take it gently. There's a threaded hole in there at the moment. It's going to be bored out, so I'm not worried if the drill wanders a little. Right, we'll have it. So, boring bar up. Let me just take a pass through there. I'm using my new power feed, which you can't hear. I'm sure that's brilliant news to all of you regular watchers. You can't hear that horrible feed motor going as it used to go. How'd it go? Anyway, so I'm going to run that through. That's a 0.15 cut. I'm just truing it up first and we'll have a measure. I've got 10mm boring bar. Right, I'm going to reverse the direction of the feed now on the fly and take a spring pass coming back out again. Nice fine feed going on here at the moment. Wait till I hear the sound stop. Disengaging, out you come. Oh, that's quite some finish in there. You could probably hear that motor running now. Okay, so I think we'll start with calipers and then we'll get a bit more delicate. So, where are we? I'm up to 17. Tools in the way to keep myself square. 17.2 I'm going to call it. Set a 0 on my DRO. I think I'm going to take 0.2 at a time, do some more passes through. So let me just swap the direction of that feed again. A little bit of compound run down that tip. That's 0.2 going to be out of there, so it should be up to 17.4 already. So next cut. As I say, I'm only taking 0.1 of the pass. And I'm trying to hold this camera in my hand as steadily as I can. Not doing too badly. So, got a little issue. I'm sure I've come across this before doing the same job. My smallest telescopic, little Toyo one, don't fit in a hole under 18mm. I think it starts at like 19mm. So I have got small bore gauges, but they only go up to sort of 3/8. So I think we might have to go old school on this. That just fits in there. Okay. So I'm going to try that in my existing ToolPost. And is it sloppy? Let me show. Yes, it's sloppy. So, caliper measurement, actual measurement, let me see what we can get. 17 point, come on, get square 8. 17.7. I'm going to try another 0.1 cut out of there, and then I'm going to actually try my compound in the hole. So, another cut. That's 0.1 aside. That should take me to 17.9. We'll switch speed on. The correct direction. Oh, that's marvellous. You can't even hear that feed motor going. Okay, let's just take the spring pass. I've reversed direction. Have I? I have. I'll let that run back out again. One thing I haven't shown, my new little camcorder, or the video recorder, comes with a remote. So if I want to start and stop recording, I just push start stop. And then when it goes to sleep, on battery save mode, I can just whack the button there and it brings it all back to life. And it does all sorts of other stuff on playback as well. And I can, let's just try, no, let's do this. I can zoom in using the buttons without having to touch the camera. So that's a useful function. Anyway, that's run out the hole now. So we'll have another measure. Let's turn that feed off. So, proof of the pudding's in the eating. That goes on. Okay, so if my compound fits, there's likely to be a little bit of wear on the register on my compound. So I think that's it done. I do want to put a little brake edge on there. I think what I'll do, because I'll probably be doing this on the back, so just get the Noga and just put a little chamfer on there. Okay, so out you come. That's the first part of the job done. Oh. And flick him over, just deburr the other side. Okay, so yeah, it's bored out and it fits. Let's just double check now I've taken it out the vise. I'll out the chuck. Happy days, that goes in there. So I've just bolted it on and done the nut up, and it does fit now on my compound slide. Height wise, let's see, I've got a tool holder. I believe that the tool holders, bear with me. What have I done with it? There it is. Little cardboard box with one of the tool holders in. Let's open this carefully. There we go. It seems quite a nice finish on this knife. It does seem quite a nice finish. I think if they were the next size up, it'd be quite a tidy thing. I might even get one of these for my mini lathe going forward. This looks like it's designed for quite small tools. Looking at the depth of that slot, it's about 8mm. So yeah, anyway, we'll pop that on there. Up is where I need it. Okay. I think what I'll do is put this now over on my lathe and just check out where the center height is, in case we need to take something off this plate, or maybe this plate's not going to be any good, just to see what the center height is going to look like. So my riser block is approximately the same height overall as the compound slide, you know, might be half a mil in it. So I've just dropped the tool to the very bottom on the slideway. When it's fitted up, as it will fit, the stud isn't long enough. I haven't been able to put the stud in, but not to worry. And I've got centre height a good 10 mil. So if you were to put a piece of, let's say, 10 mil square tool steel or high-speed steel in there, the top face you could still use the 10 mil, even though the slot width is only 8 mil to take 8 mil square tools. I would have thought that's what it's set up for. So yeah, centre height wise, it's certainly not set up too high. And if I screw it all the way up, hold on, let me just do this. If I bring it flush to the top and just tighten it up, obviously there's plenty of height there because the centre's now at the very bottom. So, you know, if you're using a form tool made out of an old file, 3 or 4 mil thick, you could still do that. I've seen that done. A form tool ground on the end of a file, an old file, and used to, not the best thing because they can be very brittle, but I've seen that done for machining like aluminium, brass, you know, softer materials. And just on another note, even though these are chemically blued, everything is, all the surfaces, the dovetails, everything, even in the edge of the dovetails, it's all ground on these blocks. The slot is ground, everything's ground. And much the same with the main body, it's all ground finishes, as you can see. It is a good hard enough steel. I found that when I was machining the base. So yeah, I'm quite impressed with this little tool post. The only thing that would get me, if I were using it on my mini lathe, you know, I'm not thinking obviously a tool post this small for my lathe. I've got a perfectly good tool post that I made, but for the mini lathe, it might be a route I go down, but I'd probably want the next size up. I'd have to figure it out. I will check this out though, for height wise on the mini lathe, and just see if this is going to be practical. It may be possible that 8 mil, you know, 8 mil tools in the mini lathe might work. So it's a 250 treble O. So yeah, I'm gonna suss it out, guys. So that's the stud that came with it. My stud, the Warco one's got 2 flats on it. I don't know whether they've always been on there or whether I put them on. I can't recall, but I think they've always been on there. So I'm going to put a couple of flats on here to make it easy to lock the stud down into the compound. So I got a collet block up in the vise. I got the stud in the collet block. I got an 8 mil cutter. I've measured the diameter as it stands at 9.8. So if I take 0.9 or put a 0.9 flat either side, it should bring it out to 8 mil. I've got an 8 mil spanner here ready to test it out in case I got to go a bit lower, and I've got a pin stop against the back of the block so I can rotate it 180 and get it back into the same place. So yeah, let's get this machined. So I'm just going to come down for a touch off. There we go. I've got X locked. Okay, set a 0 on my quill, and I want 0.9 aside. I think I'll do 0.25 at a time. Speed that cutter up a bit. That's 0.5. Like 7, and that's 0.9. That looks a big enough spanner flat to me. Okay, quite tough that stuff. They haven't used rubbish to make it out of. I'll just flip the collet block out, flip a 180, back in, against the stop, lock the vise, come back up, start the cutter. Where are we? We're back off again. I'll I'll take 0.8 off and check the spanner. Quick bozo check, that's 0.7, doesn't fit. And then worse than an odd size, we've got to use an adjustable. There you go, that'll do. It went from not fit to fit in 0.1 of a cut. So that's 2 flats put on, a little deburr on there with a needle file, and I think that's the job done. Okay, so let's give this a try. So we got the 2 little flats on there now. So screw that into the compound. 8mm spanner. That's tightened into there. Put the spacer block on. On with the tool post. On with the nut. Weirdly 14mm. 14mm spanner. Tighten it up. And that's this little tool post fitted onto the Warco. So, yeah, it's too small for this lathe. Your next size up, whatever that might be, I don't know. I think this, I don't know, I've never looked into buying one of these, but I'll certainly look into size-wise. I think I'm going to just have a quick suss out for the mini lathe, because this might be good for that. So this is sort of 40mm square-ish, maybe 50 overall. It's about 46 across the dovetails both ways, and its overall height is about 40 or 50, depending on which bit you want to measure. So just call it a 50mm cube. I think a better tool post for the Warco might be something like a 60mm cube, but who's to know, who's to know. Good thing is that the tool post being set back, or the tool holders being set back, I've put it away again now, your cutting force is closer over the compound, so that's a good thing. It's not hanging out over the edge. I mean, that's never a bad thing. I just worry about rigidity, but it depends what you're doing with it. It's certainly a nice bit of kit. I've just dropped it over the pin on the mini lathe without the subplate. And I think straight out of the box, one of these tool posts would fit on a mini lathe a treat. So yeah, I'm going to bear that in mind. I may think about something like that to go on this lathe. You know, the mini lathe that I've got that has been hiding in the corner for however long, over 12 months, that's for sure. But I may look at a tool post like that to fit on there. I quite like the sliding V style as opposed to the piston type that I made, but I think it's quite in proportion for a mini lathe. It's spot on. So yeah, as you can see, the bulk of the one I made, this cast iron one, it's a piston type, and that's a sliding V type, which probably is better. Yeah, the proportions, this one's 50mm high with its spacer by 50 by 50. Well, it's about 46, and this post is 50mm high by 60 by 60, so I've got quite a bit more heft in mine, but it all depends what you're doing with it, whether you're taking heavy cuts, light cuts, you know, it all depends. I think we might have a bit of fun and games trying to part with this one, but it all depends what you're doing, I suppose. But as I said, this tool post, perfect for a mini lathe. So this mini lathe, it's been stuck in a corner far too long. Maybe we'll do something with it this year. I think perhaps I'll pull it out, strip it all down, give it an inspect, and formulate a plan what we're going to do.